Okay, so I'm just going to go through each one of these problems. You can fast forward the ones that you already know how to do or just double check them. Slow down, rewind, pause. Make sure you are teaching yourself how to do these, not just getting the answers down. If it's factorable, if you're finding the zeros, if it's factorable, go ahead and factor it. Two numbers that multiply to make 12, add to make 7, you've got 4 and 3. Solve each factor. That one is -4, that one is -3. You can always plug them back in for x, and when you hit equals, it'll come out to 0. Problem 2, they have a common factor of x. Set it equal to 0. Take the x out of the equation. Divide it. What's left is x squared minus 4. You can either solve by algebra or you could factor x squared minus 4. It is the difference of two squares. 3 x's, or 3 for the exponent, means there should be 3 zeros. Your first 0 is here. Your second 0 is the solution to that factor. Your third 0 is the solution to that factor. Plug it back in, double check your answer, or graph it and check for those 3 zeros. Number 3, you can try to factor this. Nothing multiplies to make 14 and adds to make 10, so we'll do the quadratic formula. Quadratic formula is the opposite of b, plus or minus the square root. Always put this b in as a positive. A positive squared will always be positive. Minus 4 times a times c all over double, whatever the a is. Do the discriminant first. 10 squared is 100. 100 minus 56. You get -10 plus or minus the square root of 44 all over 2. You're going to want to break down the square root of 44 into 4 times 11, which is 2 square root 11. Now, on the simplifying of this, be a little bit more careful. You get 2 square root 11 over 2. You can't just simplify one of the two terms. Preferably, you write them separate. Reduce each one on its own. You'll have -5 plus or minus the square root of 11. Those are your two zeros, one of them being the plus, one of them being the minus. Another greatest common factor in here, they all have a 2 in common, they all also have an x in common. X squared minus 4x plus 6 equals 0. You can try to factor that as well. Nothing is going to factor into that, so you need the quadratic formula again. Quadratic formula work with just this. This will be one of your other zeros. Opposite of b is +4, plus or minus the square root. +4 squared. Otherwise, you have to put it in with a negative and an extra set of parentheses. Shorten it. Anything squared is going to be positive. -4 times 1 times 6. All over double the a, and the a is on the inside here, so all over 2. 4 plus or minus the square root. You've got 16 minus 24, which is -8, all over 2. Yes, it's imaginary, but you can still count that as a 0. Break down the square root of -8. You're going to get 4 times 2 and an I, so it's 2 square root of 2I. Write those again as separate fractions. 4/2 plus or minus 2 square root of 2I all over 2. Reduce, and you get 2 plus or minus the square root of 2I. Make sure your I is after the square root of 2. And don't forget this one, you also have 2x equal to 0, which means x equals 0. So you have x equals 2 plus square root of 2i, 2 minus square root of 2i, and 0. You have 3 zeros. 2 of them are imaginary, 1 of them is real. Next up, problem number 5. Find the zeros of this one. Again, common factor. You don't want a negative leading coefficient, so factor out a negative 2x squared. You're left with x squared minus 1. Set it equal to 0. Negative 2x squared, you can factor this. It's a difference of 2 squares again, x plus 1, x minus 1. Solve each term separately. There are 2 zeros here, or you could say x equals 0 with a multiplicity of 2. You've got 1 there and 1 there as the solution of that. Your 4 zeros. 0 twice, negative 1 and 1. Number 6. Find the zeros of this one, setting it equal to 0. Again, greatest common factor. They have x cubed as a common factor. You're left with 3x minus 4 equals 0. Set each factor equal to 0. That's going to give you 0 with a multiplicity of 3. Over here, if you set this equal to 0, you have to add 4 to both sides, divide by 3 on both sides, and you get 0 and 4/3 as your two answers for x. Next, problem number 7. Again, I'm going to remind you, don't forget that you can pause these anytime you need to. I'm going through them quickly. You can check your answers or you can slow them down, double check, make sure you know how to do these. Common factor in this one is 1/3. Take out a 1/3, you're left with x squared plus x minus 2 equals 0. This is factorable. 1/3 x plus 2, x minus 1 equals 0. Should have 2 zeros. You can't set 1/3 equal to 0 because 1/3 will never equal 0. This x you get as a negative 2. That x you get as a positive 1 for your two factors. Number 8. Find the zeros of this following polynomial. It's possibly factorable. Otherwise, you can use the quadratic formula. Let's see if we can get this to factor. Well, you know the only way to get 1 in the back is 1 times 1. It has to be a negative, and that has to be a positive, so therefore they're both negative. You got to factor the 2x, and their only options are 2x and x. Double check, see if that works. 2x squared minus 2x and minus 1x, which is minus 3x plus 1. Set each factor equal to 0 and solve. This one you'll add 1 to both sides. Be careful on your division. Way too many common mistakes on the division here. You'll say x equals 2, when in reality x equals 1/2, and over here x equals 1. Again, 2 zeros. Number 9 is our next. Find the zeros of this following polynomial. You can use the quadratic formula using 0 for b. You can factor it, sort of, or you can solve it algebraically. Try to isolate the x. Minus 25 from both sides. X squared equals 25. Negative 25. Square root both sides. You can't square root a negative. You can square root of 25 and get 5. Because it's a negative, it's imaginary, and you will need both the positive and the negative of 5i. 2 zeros again, they're just both imaginary. Number 10, looks like we're going to need the quadratic formula on this one. Take the opposite of b. The opposite of negative 4 is positive 4. Plus or minus the square root. And again, don't put negative 4 squared unless you want to use an extra set of parentheses. Positive, always use b as positive in here. 4 squared minus 4 times a, which is 1, times c, which is 1. All over double whatever the a is 1. Take care of the discriminant first. 4 plus or minus the square root. You've got 16 minus 4, which is 12 over 2. Again, no reducing, no simplifying until you break down the 12 into 4 times 3, which is 2 square root of 3. Some of you prefer to break down into a full tree, which is fine. If you have a pair of 2's, you take one out, you leave the leftover on the inside. 4 plus or minus 2 square root of 3. Put each one of them over their own denominator so that they can be simplified properly. You find the zeros at x equals 2 plus or minus the square root of 3. Find the zeros of this one. This one has probably been a while. Maybe you learned it in Algebra 2. Maybe you were taught it in Algebra 2 and you didn't actually learn it or remember it. We can factor by grouping. Otherwise, you could always do synthetic division, but I'm going to remind you how to factor by grouping on this one. Split it in half. Take out a common factor over here. Take out an x squared. You're left with x minus 1. Over here, luckily, if you take out a negative 16, so that you don't have a negative leading coefficient, you're left with x minus 1. How do I know I can factor by grouping? Because when you factor by grouping, they have the exact same remaining factor. That is a common factor of those two separate terms. So now that common factor gets factored out of this part of the equation. Set it equal to 0 as usual. What are you left with if you factor out an x minus 1? An x squared minus 16. Complete factorization, you get x plus 4, x minus 4, another difference of 2 squares. Got to make sure you're recognizing those, using them properly. Your 3 different x's, you've got 1, negative 4, and positive 4. And I just broke my microphone, so we're going to pause. I think I'm going to hold it the rest of the time. Number 12, find the zeros of the following polynomial. Quick glance at this, I don't think I can factor by grouping on it, because if you take out an x squared, you're going to be left with x plus 24. 740 divided by 214, that is not going to be 24. So our next best option is to find a zero on the calculator. So I'm going to plug in x cubed plus 24x squared plus 214x plus 270. Graph it. I can hopefully find one whole number 0 so that I can use synthetic division to find the others. So I'm going to go to the graph, calculate the value at 0. So go to number 2. Let's see if I can find my cursor. Too high, too low. my left boundary is going to come onto the screen too low, so I'll go up 1. My right boundary can be over there, and it looks like there's no sign change, so I screwed that up. Quit that, graph again. Maybe let's zoom out and see if we can't see a better picture of the graph. We'll zoom out up here. Same idea. Zoom back in and I'll just do a better job of calculating my zero this time. That's why. That says 270 instead of 740. I was way off. You probably already noticed that. That looks like a 0 over there I can work with. Calculate the 0 this time. Left boundary. I got to come down. I'm way up at 365. There it is. Right boundary. If I had to guess, I would say it's at -10. Guess. I found a 0 at -10. It's an x cubed problem. I need 2 more zeros than -10, which I may find out to be imaginary. But at least now I know one of the zeros. I'm going to use 1, 24, 214, and 740. Drop down the 1, multiply, get -10, 14. Multiply, get -140. 214 minus 140 is 74. -10 times 74 is -740, which means I have a 0 there. What's left? X squared plus 14x plus 74. Not even going to try to factor that. Let's go right into quadratic formula.
Excuse interruption. Attention FFA. Please report to the Cal Center at this time for the group picture. FFA to the Cal Center, please.
Pardon the interruption. There's 2. I'm going to calculate 14 squared minus 4 times 1 times 74. Get -100. That's a nice number to work with. Square root of 100 is 10, but it's imaginary, so we need 10i. Divide each one of them by 2. Final answer for your zeros. X equals -7 plus or minus 5i. There's 2 different zeros. And don't forget the -10 that we found first on our graph as our other 0. A little bit more complicated to go by synthetic division, but it is an option for solving. Alright, 4 problems left. Find the zeros of this one. Because this is an even number, you can still consider this a difference of 2 squares. X squared plus 9, x squared minus 9. Solve each one of these. X squared plus 9 equals 0. X squared minus 9 equals 0. minus 9 from both sides, you get x squared equals negative 9. Square root, that's imaginary. You have both a positive and a negative 3i. Add 9 here. X squared equals 9. Square root both sides. X equals a positive and a negative 3. You'll have 2 imaginary numbers, 2 real numbers. Finding the zeros of this, that looks like a parabola in standard form. You've got the A, you have H, K, it's all set up for you. You could FOIL this out, distributive property, set it all equal to 0 and use a quadratic formula. But much faster would be to just use algebra, try to isolate the x. Order of operations in reverse order. 4 times x minus 6 squared equals 7. Divide by 4 on both sides, and you get 7/4. Not a nice number, but doable. X minus 6 squared equals 7/4. We're going to square root both sides. When you square root a fraction, you square root both the numerator and the denominator. That can be simplified, I don't need the parentheses anymore, as x minus 6 equals the square root of 7 over the square root of 4, which is 2, and you're going to need both a positive and a negative. Add 6 to both sides. Those are not like terms, so we'll leave it in standard form. 6 plus or minus the square root of 7 over 2. Find the zeros of this one, just a little bit more complicated. Looks easier, but what happens here when we add 2 to both sides? 5x squared equals 2. Divided by 5, you get x squared equals 2/5. But again, when you square root, you need to square root the numerator and the denominator. It's not okay to have a denominator with a radical in it. It's against math rules. So we rationalize the denominator. Multiply it by itself. Square root of 5 times the square root of 5 is 5. Square root of 2 times the square root of 5 is the square root of 10. Because you square rooted it, over here you have both answers, a positive and a negative. Square root of 10 over 5. Not able to simplify. One's a radical, one's a whole number. Leave them alone. And if you're wondering, before we do the last one, quick check. I want to know if that's correct in the calculator. So I'm going to put in we'll quit out of there. What was it? Plus or minus the square root of 10 over 5. Of course, I can only do one or the other. I can't do both. Square root of 10 divided by 5. Store that for x. Do the math. 5x squared minus 2. 5x squared minus 2 equals 0. More than likely, then the negative square root of 10 over 5 is also going to work. We'll check it. With 5x squared minus 2, and that also equals 0. So you could always take these and plug them back in and check and see if they work, or check them on your calculator. Last one, problem number 16. Let's take out a common factor of x squared when we set this equal to 0. You're left with x squared plus 4x plus 10. Not going to be able to factor that. One more shot at the quadratic formula. Negative b plus or minus the square root. B squared is always positive. minus 4 times 1 times 10 all over 2. Double the a, 2 times 1. Do the discriminant first again. 4 squared is 16. 16 minus 40 is probably about 24, but it's negative. We're going to break down the square root of negative 24. We can do it the long way if you want. 6 times 4, 2 times 3, 2 times 2. Since you have a pair of 2's, one of those comes out. Since you have 2 times 3 left over, those go in there. And you also have the square root of a negative 1, which would make that an I. Negative 4 plus or minus 2 square root of 6 I over 2. Careful on the simplifying one more time. Negative 4 over 2 plus or minus 2 square root of 6I over 2. This is a complex number. They have to be written separately, reduced separately. Real number goes first. Imaginary number goes second.
Attention staff, please dismiss the archery club at this time to the Cal Center. Archery club?
This is 2 zeros because you have the plus and the minus. It started out as x to the 4th. Our other 2 zeros come from x squared, which means that we have 0 with a multiplicity of 2, or 0 twice. And there's your zeros. Rewind and relearn. Remind yourself if any of those are difficult for you.